again with you, okay, the pioneers in methods, okay, and it will be only today is 20, okay, it remains only few days for examining your final exam, okay, and your pioneers in methods is already looking for giving you extra ideas and extra questions, okay, that let's say that have been taken from this previous last exam, okay, of math, of course, for grade 12. Okay, so I will just explain something for you learners. Okay, entire screen. I'm looking for entire screen. Okay, I will share this with you. So learners, as we told that, in fact, please don't forget to subscribe in say in my channel and consider it your channel because it let's say offers you let's say I will change this one. Okay, change. This is about differentiation. I will just change after inshallah. Okay, so I will go back to this one. Shall I change this? I will see if it is possible. Okay, what is OBS? Not OBS Studio. Okay, this one streaming online. Okay, so I will just try to change this as I'll just write okay differentiation differentiation okay, and the trig function if you found time and trig function, okay, so just I will erase this, okay. Now, okay, now I will education. Next, I'll do next here. So, okay, now at least it comes. Okay, I'm going now to a destination no need. I'm going to work here. So the question learns is given that y equal third x cubed minus 2x, find the range of values of x for which y is an increasing function. So first of all, you should learn it's 3 out of 3 marks. You should, let's say, differentiate your function. It will be y dash equal 1/3 times this is 3 will come as here. Then I should subtract here 1. So it will be 1/3 multiplied by 3. Okay, I can cancel this 1 by 3 is 3 divided by 3 is 1. We'll cancel this after. Therefore, x3 minus 1 minus the first derivative of 2x is minus 2. Therefore, the answer here it will be x squared minus 2. Then to find the stationary point or to find the values of x for which the range is of my function should be increasing function, I should set y. I'll just let here set y dash equals 0. Okay, set y dash equals 0 means the first derivative of the function should be equal 0. Therefore, I will write this one should be equal to 0. I will just write x squared minus 2 equals 0. Therefore, x squared is 2. To find the roots of this quadratic equation, you should take the square root for both sides and don't forget about the negative sign and try to leave your answer as such. Just mean that x is negative root of 2 or x is root of 2. Therefore, learners to find the range of this function after, let's say, setting y dash equals 0, you should construct values of table, okay, contains the roots of, let's say, or of y dash. Okay, when y dash equals 0, we found these two values, x equals negative root of 2 and x equals root of 2. Therefore, try to choose some numbers. For example, me, I choose between negative root of 2 and root of 2, I choose 0. You can choose 1, okay. You can choose 0.5, okay, 0.25, 0.75, whatsoever. And here, after, let's say, x equal root of 2, I choose an x equal to 3. You can make 2, for example, okay. This is depends on you. And before a negative root of 2, I choose x equal negative 3. Therefore, to find this is the sign of y means at this point, try to find the value of the first derivative of the function when x equal negative 3 will just replace y dash equal negative 3 squared minus 2. Negative 3 squared learns is 9 minus 2 is 7. Therefore, the sign of y dash learns is positive. That's why I put positive sign. Okay, and I use this arrow to show that this function, okay, for x is less or equal than negative root of 2 is an increasing function. Okay, now for this one, when x equal negative root of 2, so the sign, the y dash, it will be a 0. Okay, so it's a inflection point, it can be minimum or maximum. Okay, now here, in fact, it's a maximum, okay, because the first derivative of the function, the second derivative of the function, okay, at this point should be negative, okay. Therefore, learners, I'm going to see the value of x1, x equals 0. I will try to check the sign of my first derivative function, y dash. I will just replace x with 0. It will be minus 0 squared is 0 minus 2, so it will be a negative. I just put a negative sign to show that my function, the curve of my function, okay, from negative root of 2 rated up to root of 2, my function is a decreasing function. And then, as it is decreasing function, so I'll just put this row to show you that is a decreasing function. Okay, so this is, it's increasing and this is decreasing. So this one, it's a maximum point. Okay, it's a inflection point, it's called. Okay, it's a maximum. And this is also, we can call as a critical points, okay, when the curve change direction. Okay, for x equal root of 2, just the first derivative of the function is 0, simply because the root of 2 and negative root of 2 are the roots of my first derivative of the function. For x equal 3, I told that you can choose x equal to x equal 1.5 more than the root of 2. You can also choose the root of 3, okay, because 2 is less than 3, therefore root of 2 is also less than root of 3. So therefore, changing x with a 3 in the first derivative of the function, I will obtain 3 squared minus 2 equal 9 minus 2, so 7, so this one is positive. The full learners to find the range of my function, the range of values of x for which the function is increasing. It's clear that x should be less or equal than negative root of 2, and also x should be more or equal than root of 2, because root of 2, it's let's say the root of my first derivative function. Therefore, I will write range here. Okay, I will change this with another color if it is possible, of course. Okay, I'll change with the green. Okay, this is the last answer. Okay, not clear. Okay, I'll make. I will change this with. Okay, give me time first. I will change this by white. I'll see if we have white, blue. Yes, blue approximately it comes. This one, no. This one, no. This one, Bardo, no. This one, no. Or this, no. This one, no. This, then, so approximately it will be green, it's better. Or this one, blue, yes, blue, okay. So this is the range of my function. I will tell that x is less than or equal to negative square root of 2, or x is more than or equal to root of 2. The full learners x, it's belonging to what? To it's x belonging to the interval, okay, opened from the left hand side, which is minus infinity, okay, minus the interval, okay, opened from the left hand side and closed from the right hand side, because negative root of 2 is root of my first derivative function. Union what? Union root of 2 plus infinity. Okay, this is the range of this equation. Okay, now learners, I wish that's clear for you. Okay, I will make this one, I will make small so that I will okay, obtain the space 11 or 12 Or 14. Yes, that's 14. So I will save this one, learners. Okay, this is how can you find the first derivative of the function, and how can you set the y dash equals 0 so that to find the x value for which your function should be an increasing function. If the question is looking for a decreasing function, we'll tell that the range is more than negative, more or equal than negative root of 2 and less or equal to root of 2. Okay. Then we move to the next part. Okay, this is I will choose another question. Okay, I'll go to another question. Okay, okay. This is we did it. May I will make copy for this. May I will need this one. By the way, we continue. This is we solved about probability distribution and expectation value or mean and variance and standard deviation. Okay, I'm looking for an exercises. Okay, this is also we do this one. Learners, it's very important. Okay, try to focus on this example because so that will never be surprised while examining. Okay, for the next part, I would say this one. Okay, we have okay. I'll just use this one. This is we did before. Okay, and then we told that prove that z equal to is a root. Okay, and z to the power 3. Okay, just I will change this by negative 4. Okay, and I will change this by okay by plus okay 64. Okay, that now we are going to use exactly the first let's say the theorem of remainder theorem or remainder factor theorem. Okay, you just make like that. Okay, I will paste this here. I will put this here, learners. Start solving. Okay. Yes. Now learners, we have z to the power 3 plus this is my function. Okay, f of z, of course. F of z. Okay. I'll just write it here. This is f of z. I will just put here f of z, my function. F of z is equal to this. Okay. The question is prove that z equal negative 4. It's a root. Therefore, you will use remainder theorem. Okay, remainder theorem. Remainder. Sorry, remainder theorem. Okay, states that f negative 4 should be equal to 0. Okay, f of negative 4 should be, in fact, is the remainder. It's the remainder. I will just suppose that it's the remainder. Okay, the full learners. Okay, okay. I will try. Sorry. I'll try to cut this one. Okay. With all the okay, I will try to erase all of this. No need for the next. Okay, cut this and cut all of this. Okay. Yes. Okay. Now, as we call the remainder theorem states that if a is a root, therefore f minus 4 should be equal to 0. This one, it's called the remainder is r. Okay. Now I will just calculate f of negative 4 and I will check. Okay. Therefore, learners, I will just write it here, of -4, okay, because the question is prove that z equal -4 is a root of f of z. I will just put here, place z with -4, okay, then I will erase this one. Or this one learns equal -46 plus 46 should be equal to 0. Therefore, I'll just therefore as a conclusion, z equal -4 is a root. Okay, is a root. Therefore, z equal -4 is a root. Okay, is a root. Now, learners, after that, hence to solve for z, you are going to let's say find a z square plus bz plus c, okay, because this point function can be written as that. I'll just show this one for you. Therefore, this one, learners, I will just write this as that equal, in fact, between parentheses z plus 4 between parentheses times a z square, okay, a z square. I will use this one, a z square. Sorry, sorry, sorry. Okay, I will write it here, a z square. I will use equation. Okay, a z square plus bz, a z square plus bz, okay, plus c. Okay, all learners means that you can use long division plus f of plus f of -4, okay, but f of -4 is 0, so it remains only this one, okay. Therefore, learners, this one is equal to that, okay, is equal in fact to this, okay. Or you can go back to definition. I can, let's say, find a and b. I will just write it down. Okay, I'll write all of this if it is possible. The full learners copy and make paste here. So I will just f of z equals z plus 4 times, now I will change this as z square plus here minus, because minus 4, okay, minus 4z plus 16 plus 16 16. Then this one should be equal to 0. Therefore, y here I used, because did you remember this 64? I can write it as 4 to the power 3. Okay, I'll just write it here as z 4 to the power 3. Okay, and I will erase this one no need. So this is a formula: a cubed plus b cubed. It will be a plus b times a square minus ab. Okay, z plus b squared. Okay, therefore try to solve this equation. Okay, equal 0 means that learners, okay, equal 0 means that z equal -3. Okay, or I'll just write this one. Okay, copy means that learners, I will, what is okay, means okay, gives this one equal 0, okay, or z square, okay, equal 0, or okay, or this equal 0, okay. Therefore, the first one we proved that is in fact equal to 0. Okay, I'll just solve this equation, solve the next one. Here you can see that a is 1, b is -4, and c is 16 if we are going to use long division. Okay, and it will be exactly, I will use the formula z is equal, okay, between parentheses I will use quadratic formula. I will make here like that, minus b means minus 4 is 4 plus negative root of I'll just use this one, root of what, learners? Root of negative 4 squared. I'll just write as it is. Between parentheses I'll make negative, okay, negative 4 squared, negative, between parentheses of course, negative 4 squared, okay, minus what, minus 4 multiplied by 1 multiplied by 16, minus 4 multiply, okay, minus 4, okay, minus 4 multiplied by 1 multiplied by 16, okay. This is the value of the discriminant. Divide by what, learners? Of course, divided by, okay, divided by 2. Okay, 2 times a means 2 times 1. Therefore, I can calculate this. It will be equal to, I will just make this one is equal, okay. I will calculate what is inside the square root. It will be negative 4 squared is 16, okay. Minus 4, it will be multiplied by 1 multiplied by 16, negative 64. Negative 64 plus 16 gives negative 48. Negative 48. I got 14. Negative 48. I'll just write here. Negative 40. Negative 48. And the value of the discriminant is negative, so therefore I will write this as that. Okay, you can appear that 48 is let's say 16 multiplied by 3. Okay, this is equal to, we told 16 multiplied by 3, then minus 1 is I squared, therefore it will be 4i, okay, 4i root of 3, okay, root of 3. Therefore I simplify this, as I can also simplify by, let's say, I will make I here, okay, the complex, okay, imaginary part, okay. I will just write now the last answer is that, okay, so we have two roots. It will be equal, in fact, to, okay, we told, I will make this small, learners, okay, go 15, make 14, yes. So this one, learners, is in fact 4 divided by 2 is 2. I will write here 2, and this is also should be 2. This is the last answer. Okay, I'll just change the color for you. I wish that's clear for you, learners. Okay, and red, it's better. Red, it will be clear for you, maybe. Okay, this is now red. All that. Yes. Okay, this is the answer, learners. I wish that's clear for you, and we can do it. Okay. For the next question, I'm looking for seeing what can we do here. Okay, if the gradient okay, of a curve is given by y, show the curve has a maximum point on. Okay, first of all, you are going to, okay, I will start doing this question. It's very important. Okay, I will write it here. Okay. Okay, or I will use one of this. Okay, I will use a fraction. I need just only the symbol of fraction. Okay, the rest no need. Okay, I will come as have learners, and I will insert now a table. Where shall I solve this equation? Okay, this one. I'll just put like that. Okay, then I should insert a text. Add a text, Mr. Murad. Okay, then copy. Now, learners, you can see that y dash in fact is, I will just write y dash is equal to 2x 2 times x minus y divided by x plus 2y. Okay, this is my first derivative of the function. Okay, the question is told you that if the gradient of the curve is given by, show that the curve has a maximum point value, okay, at the point -4, okay, -4, 8, okay. First of all, this is why if I'm going to change by -4, 2 times -4 is -8. -8, it will be -16. Then x is -4 plus 2 times, 2 times let's say 2 times 8, it will be -4 plus 16, it will be 8. Okay, let's now learn to differentiate my function, okay, or just tell that set y equal, okay, set y dash, I call that y dash, yes, y dash equal 0, okay. We'll obtain 2x minus y, 2x minus y is 0, okay. I'll just write like that, equal 0, therefore 2x or y equal, as you like, y equal 2x, okay. This is the value 1x, for example, okay, 2x equals 0, therefore this is okay, or we put a minus, there is a minus here, okay, y dash is a minus here, is minus, okay, so I'll just put minus here, there is a negative sign, don't forget, therefore y in fact is equal to -2x. Look here, 1x is -4, okay, so y is in fact -2 times -4 is 8, okay. And now I'm going to differentiate, let's say, so therefore I can tell that the point B or A, as you like, of course, coordinates -4, okay, -4, 8, 8, what is 8? 8 is the stationary point. Is the stationary point. So it can be a maximum and it can be a minimum. Okay, it's called the critical point. Therefore, learn is to figure out this one. Okay, I will just okay, I will cut this first. Okay, I will write it down. Therefore, okay, like that. Therefore, the point is the stationary point on the curve. Okay, now we need to find the curve, the equation of y, because you will integrate this, and the integration will be next step. Therefore, learners, I should now differentiate this again. I will make like that. Okay. This is my function. Okay. So I will use. I will multiply. This is. I will suppose this is y divided by 1. I will write it here. I will insert equation. Not equation, fraction. I will write this is y dash. Okay. And this is 1. Then I will erase this one. This is in fact is y dash over 1 is y dash. Therefore, cross multiplying means y dash multiplied by x plus 2y equal minus 2x minus y multiplied by 1. I'll just write like that. This is cross multiplying. Okay, cross multiplying. I will write it cross multiplying. Multiplying will give me exactly cross multiplying will give exactly learners x plus 2y. Okay, will give exactly like that. Okay, between parentheses x plus 2y, now parentheses multiplied by y dash equal in fact minus 2x minus y multiplied by 1, it will remain the same. Minus 2x minus minus y. Therefore, I will just write this as, okay, this will give me x multiplied by y dash plus 2y multiplied by y dash. Okay, I can simplify this as that. Okay, I can simplify this by that. So this will give me exactly the following. Okay. Okay. I will just write this as that x by y is y x x y dash. I will just write the x y dash. Then 2y multiplied by y dash, I will just write here plus 2y y dash. Okay. Then equal what? In fact, equal minus 2x minus y. I'm going to differentiate this bonus. Okay. I will use differentiation. Okay. Go back here. I will make like that. Now I will differentiate this. It will be the derivative of this. I will just write. I will differentiate x y dash. First of all, it will be y dash. Okay. Sorry. It will be okay. Then plus x plus x y dash squared, because I will differentiate this. Okay, it will be a y double dash x y double dash. Okay. Then I will move to the next one. I differentiate this. I'm going to do this one. It will be 2 times. Okay, 2 times. I will differentiate with all this function. It will be learned as a fact equal 2y means 2y dash. Okay, with respect to with respect to x, it will be okay 2 times y double dash. Y double dash. What is y double dash? Sorry, y dash multiplied by y dash plus what, learners? Plus 2y y double dash plus 2y y double dash. Okay. And I will move to this one. The first derivative of the function is minus 2. And this is the first derivative of the function y is y dash. Therefore, I will write, you can see this one here, y double dash. Okay. And here, y double dash. Okay. So, okay, to y double dash, yes. Now, and this is y dash multiplied by y dash is y squared. Okay, I will just write this again. It will be equal, I need the equation on z. Okay, yes, this one. Therefore, learners, yes, I will put, let's say, y dash double dash into let's say, where is double dash? I will put y double dash into parentheses. I will make y double dash the second derivative in parentheses multiplied by what? Multiplied by x, the first one. I will make x plus. Then we have 2y double dash, so plus 2y. I will close this parenthesis. Okay, you see now this one y dash. Okay, this one and 2y dash squared. I should transfer on the right hand side. Okay, it will come like that. This is minus 2 minus y dash. I will write as it is minus 2 minus 2 minus y dash. Then, learners, with all this is y dash, I should transfer on the right hand. It will be minus also y dash. Then minus 2y dash multiplied by y dash, I will transfer on the right hand side. It will be minus 2 times y dash squared, because y dash multiplied by itself. Y dash squared to the power 2. Okay. Therefore, I will divide both sides by x plus 2y. Okay, I can simplify this also more. It will be like that. Okay, copy and go back. Therefore, we told y dash in fact is equal to okay, equal to, we told minus 2y minus 2 minus y dash. I will cut this. I'll put it here, but I'm going to add y dashes. It will be minus 2y here. Okay, minus 2y dash divided by what? By x, divided by x plus 2y. Okay, x plus 2y, because I will divide both sides by x plus 2y. Okay, I will now erase this one. Yes. This is y double dash. Okay, I will extend this learners. Now it's clear for you, isn't it? Like that. Okay. This is the second derivative of the function is minus minus 2 minus 2y dash minus 2y dash squared. Okay. We don't have here is what is minus 2x. Yes, minus 2x. This one minus 2x. I will write it, no change. Or is it minus 2x? Just okay. I differentiate this. We already differentiate this. Yes. خلاص, it will be minus 2. Okay. The full learners now when x equal negative 4. Change this by the second derivative when x equal negative 4. Okay. Therefore, at x equal negative 4, let's see this one. How it will be minus okay, negative 4. I would say it is minimum or maximum. Okay, negative 4, negative 4. Mhm. So we put y dash, okay. Or we can use another, okay, I will use another method. I will try to use another method. Okay, I will use another method, learners. Y double dash minus 2. Okay, it will be minus 4. Minus 2 times. Okay, minus 4 plus. Okay, no problem. Look here. First of all, I should calculate y dash. Y dash when x equal, this is y dash. When x equal negative 4, negative 2 multiplied by negative 4 is 8, minus 8, so y dash is 0. Therefore, okay, at x, I will obtain only this one. Okay, y dash, we called here y dash. I will just write here y dash when x equal negative 4. I'll put here. It's called comma y dash when x, sorry, y dash, yes, when x equal negative 4, negative 4, it will be equal to 0, equal 0. Okay. Okay. Now means y dash is 0, y double dash, y dash squared is 0. It remains only minus 2 divided by, I will just write it here, minus 2 equal, learners, minus 2 divided by x plus 2. Minus 2 minus 2 divided by x plus 2y. When x now is minus 4, it will be in fact copy and complete, copy and paste, equal what, learners? Minus 2 divided by minus 4, this is minus 4, plus 2 times 8. Okay, so this one is equal also, equal, I just put like that, minus 2 gives minus 2 divided by, yes, gives minus 2 fraction, yes, gives -2 learners divided -2 divided by 16 minus 4 is 12. So it will be -1 equal -1 over 6. Negative 1 over 6. So it is negative or positive? Is negative, means it's a maximum. Okay, 1 over 6. Okay. This, the second derivative of the function when x equal -4 is -1 over 6, and it's written in simplest form. If you use, let's say, the method of when you differentiate a quotient, you can differentiate, use the quotient rule, you'll find, let's say, a number bar is not written in its simplest form, so we should divide by the highest common factor. So therefore this one is negative, learns is negative, minus between parentheses is negative. I'll make less than 0, it's better. Less than 0 means what? Means it's a maximum. بين قوسين maximum. Okay, it's a maximum. So I wish that's clear for you. It's a maximum. Okay, I hope so. You got the point. So it's a maximum. So at this stationary point, x equal -4, y equal 8, it's a maximum. Okay, just I will extend this a little bit. Yes, doesn't count. Okay, no problem. I will make all of this. I will make a CD 13, 12. I wish that's clear for you learners. And now I'm going to stop sharing. Okay. Save this first. Okay. Let's stop. This question. Okay, the charge will stop. Learn so the next time we'll focus on this. Okay. This question we'll do it after, because the laptop will shut down now. Okay, I will hope so. I will try to do it if it is possible, of course. Okay. I will add the text. Okay. Okay, now I'm going to make regular. Okay. Therefore, the first derivative of y dash is equal. I will insert equation. Y dash means the first derivative of the function with respect to x. Okay. I'll just write dy with respect to the x, which is equal to y dash, equal, in fact, the first derivative of sec is sec tangent. Okay, is sec x tangent x, then minus plus the first derivative of tangent is sec. Okay, it's x squared, means sec to the power 3. Sec to the power 3. Sec to the power 3. Okay. Sec the 3x. Okay. Then I move to the next one. Plus the first derivative of ln x, I will just write as a fraction. ln sec plus tangent. It will be okay. It will be like that. Should differentiate sec square. Sec is we told sec x tangent x. Then plus what learns? Plus tangent it's sec square. Plus sec square. Okay, and put it here. They are all divided by what learners? divided by sec plus tangent x, x plus tangent x and up x. Okay. Mhm. Okay. So we continue this in the next time. Okay. I wish that's clear for you, learners. Okay, because خلاص it will shut down. Okay, what else? Can I